Welcome everyone, I'm Adam. In this problem, we're going to be finding the angle theta between the two lines given by the equations 3x plus y equal to 3 and x minus y equal to 2. And we'll find that angle in both radians and degrees. Now, starting with what we know that the angle between two lines can be related to their slopes through the equation given by this. The tangent of the angle theta is equal to the absolute value of the quotient of m2 minus m1 divided by 1 plus m1 times m2, where m2 and m1 are the slopes of the given lines, respectively. Now, which slope matches to which line doesn't really matter, so arbitrarily we can kind of just number them. We'll just call this first equation, equation 1, and from that we'll find slope 1, and the second equation, equation 2, and from that we'll find slope 2. So, going back to our equation, eventually we're going to solve for theta, but first we need to simplify this right-hand side by plugging in our m2 and our m1. So let's go ahead and find that. So we're going to find the two slopes simply by taking each of these equations, and we'll solve for y, or rewrite it in our slope intercept form, or y equals mx plus b, namely to find the m's. So for our first equation, like we said, solving for y, all we have to do is say subtract 3x over, and that will give us y is equal to subtracting 3x, we get negative 3x plus 3. So our m1, the first slope, number being multiplied with x, is negative 3. And do the same thing for our second equation. So solving for y, first we'll subtract x. That gives us, to start with, negative y is equal to, say, negative x plus 2. We want to get y by itself, so multiplying through by a negative 1 on both sides will give us positive y equals, say, positive x minus 2. Or namely, our m2, the number being multiplied with x, is a positive 1. Okay, so there's our m1, m2, and like we said, we're going to plug that in on the right-hand side of this equation and simplify it, and then solve for theta. So let's go ahead and do that. So once again, our tangent theta is going to be equal to this absolute value of the quotient m2 minus m1. m2 is 1, and then minus m1 is negative 3. And in the denominator, 1 plus m1, negative 3, times m2, positive 1. So we'll just simplify this. So 1 minus a negative 3, or 1 plus 3, in our numerator we get positive 4. And 1 plus negative 3 times 1 leaves us with a negative 2. So our tangent theta is, and we'll just simplify this one more time, going to be absolute value of positive 4 over negative 2, which is equal to the absolute value of, say, negative 2, and the absolute value of negative 2, is 2. So let's come over here and finish it up. So one more time, tangent of theta is equal to positive 2, and we want to solve for theta. And we can do that by taking tangent inverse of both sides, namely giving us that theta is equal to tangent inverse of positive 2. Now, 2 isn't one of our standard numbers, so we're going to go ahead and use our calculator to find this, or at least get a decimal approximation. So again, first we're going to find this in radians, and then we'll go ahead and find it in degrees. So first thing we're going to do is we'll find it in radians. So let's make sure we're in radian mode. And so simply typing in tangent inverse of positive 2. And so we're going to get that theta is approximately equal to, say, 1.107 radians. All right, and lastly, we'll find it in degrees. And we'll just switch our mode over to degree mode. And once again, just typing in tangent inverse of positive 2. And so we're going to get that theta is approximately equal to, say, 63.435 degrees. So there we have it. The angle between our two lines is approximately 1.107 radians, or approximately 63.435 degrees. Thank you very much.